Good morning, students. Today we are going to see the new chapter, exercise 1.1, sets and Cartesian products. Okay, sets you learned in lower class in 9th standard. Even you started learning the new syllabus, you learned what is sets and also Cartesian product. Now in this exercise we are going to see the same, just like a recapitulation. So few problems what is given in this exercise you learned in 9th standard and in 10th standard also. So there is no need for any recap of formulas like that. So we'll directly get into the problem. Write the following in rooster form, so that you know already how to write it in the rooster form. Okay, now see, it's given that set of x belongs to n. This n is a natural number such that x square is less than 121 and x is a prime. Okay, now you have to find set of numbers so that those numbers belongs to natural number. You know that natural number starts from 1, isn't it? And two conditions are also given, that when you square that number in the set, every number in the set, that must be less than 121 and also that number must be a prime number. So that is very important. So first we will take the first condition, which is x square is less than 121. So taking that x square is less than 121, when you bring the square to the right hand side, it becomes square root. Actually it is plus or minus root, but the question it is asked that x is a natural number. Natural number starts from 1. Okay, that means greater than 0, so there is no need of taking the negative root. So I have taken only positive root. So x is less than root 121. What is root 121? It is 11. So x is less than 11. So it means that the set of numbers must be less than 11. So from the first condition we have understood that set of numbers must be less than 11. And secondly, it is given that it is a prime number. So prime number, we know that it is 2, 3, 5, 7, 11, it keeps on going, isn't it? So combining the two conditions, we are going to write the set of numbers. So this is the required set. Since it is given natural number and prime, we are starting from 2, then 3, then 5, then 7, then it goes on 11, 13, etc. But the first condition it is given, the number must be less than 11 it is given. So prime number which is less than 11 means it is 7 only. So up to that only we can write. So it is a finite set. Okay. So 2, 3, 5, 7. So that is the answer for this subdivision. Subdivision 2. The set of all positive roots of this equation. Okay. That is an equation given that x minus 1 into x plus 1 into x square minus 1, which is equal to 0. Now you have to solve this, and first you have to find the value of x, then you have to write it in the set. So I have written the question. Now you see this x square minus 1 can be written as x plus 1 into x minus 1. Already there is an x plus 1 into x minus 1. So it is multiplicity of the root. So when you bring this 1 to the other side, it is become minus 1, and plus to the other side it become plus 1. So x is equal to plus or minus 1 is the solution. Okay, right. Now we have to write it in the set. In the question it is given that set of all positive roots they have given. Set of all positive roots. So though we have the answer plus and minus, question is the condition is given that positive roots. So minus 1 is a negative number, so we cannot take that. So we are taking only positive 1. So this set contains only one number, which is 1. You know that it is a singleton set. Then subdivision 3, x belongs to a natural number such that 4x plus 9 is less than 52. Okay, so inequality and all we learnt already, isn't it? Right. Now take this condition and first you find the value of x. So 4x plus 9 is less than 52. So when you take the 9 to the right hand side, it becomes 52 minus 9. So 4x is less than 53. When you divide, 43. When you bring the 4 to the denominator, it becomes x is less than 43 by 4. So when you divide it, you get that x is less than 10.75. Okay. So the meaning is the numbers must be less than this. Okay. Question it is given in the beginning, that is x belongs to a natural number. So our set must start from what? Natural number starts from 1. So we have to start from 1 first of all. Then it is less than 10.7. So the whole number below 10.7 means 75 means it is 10 only. So number starts from 1. It goes on till 10. So that is the set of numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Subdivision 4. Here the condition is given that x such that x minus 4 by x plus 2 is equal to 3. X belongs to real number. Okay. But there is one more thing is given. X belongs to real number minus set of minus 2. It means you can take any real number other than minus 2. That means from the set of real numbers you have to avoid minus 2 only. Leave minus 2. Leave minus 2. That means minus 2 will not be considered in the set. Okay, right. Now first you take this condition and we will find the value of x. So x minus 4 by x plus 2, which is equal to 3. So x minus 4 is equal to 3 into x plus 2. I have taken the denominator of the right hand side, left hand side as numerator of the right hand side. So multiply this 3 with the x, so it becomes 3x. 3 with the 2, it becomes 6. Now bring all the variables one side and constant to the other side. So this 3x is brought to the left hand side, so it becomes minus 3x, and minus 4 is taken to the right side, so it becomes plus 4. So x minus 3x is minus 2x, which is equal to 4 plus 6 is 10. So x is equal to 10 by minus 2, so x is equal to minus 5. So minus 5 is a real number, isn't it? It is not minus 2. Suppose if it is a minus 2 means we cannot take this as solution. So the set of answer is only one. Set of number is only one, which is minus 5. Now write the set minus 1, comma 1 in set builder form. Okay, just a reverse. It is given in this form and you are asked to write in the set builder form. Okay, so we can consider each element as x. So x is equal to minus 1 and x is equal to 1. So when you bring the x to the left hand side, it becomes x minus 1 is equal to x plus 1 is equal to 0, and here x minus 1 is equal to 0. So we can combine it, isn't it? X plus 1 into x minus 1, which is equal to 0. So this is like a plus b into a minus b formula. So a square minus b square. So x square minus 1 square. So x square minus 1, which is equal to 0. Now you can take the minus 1 to the right hand side. So x square is equal to 1. So now we have formed it. Now you can write it in the set builder form. So x belongs to 1 is a real number, isn't it? We can consider like that. So x belongs to real number such that x square is equal to 1. Now we'll go to the next problem. State whether the following sets are finite set or infinite set. Okay, what do you mean by finite set? You can count the number of elements in the set, means such a set are called finite set. And infinite set means countless. You cannot count the number of elements in a set. So first you have to frame the set, then you can say whether the given set is a finite set or infinite set. Right, first question, first subdivision. X belongs to n, that means natural number such that x is an even prime number. Okay, you know that prime number starts from 2. So 2 is an even prime number. Okay, natural number starts from 1. So our condition means you have to start from 1 itself. 1 is not a prime number and it is also not even prime number, so you can leave it. Second number is 2. So 2 is a prime number which is also even. Then go for the next prime number, which is 3. 3 is a prime number but is not a even prime number, it is an odd number. Then we'll go for the next prime number 5. 5 is also odd, 7 is odd. Then we'll go for 11. Such a way, even if it is good, if you keep on moving, the only prime number which is even is 2 only. Okay, so the number of elements in the set is what? Only 1. Okay, so it is count. You can count it. You can count the set. So it is a finite set. Now we'll go to the next subdivision. X belongs to n, natural number, such that x is the odd prime number. Okay, so you know that 2 is the only even prime number. So remaining and all, it is odd prime number. So I can directly write it 3, 5, 7, 11, keep on going. So it is countless. It means this given set is a infinite set. Now we'll go to the next subdivision, subdivision 3. X belongs to Z. Z means what? Integer. X is even and less than 10. So you know that integer starts from negative numbers, then 0, then it goes to the positive number. So first it is given that it is an even number and it must be less than 10. So we can go from the reverse. We start from minus 10. Less than minus 10 means we cannot include that. You will leave that to the next. That means the previous number to 10 is, previous number which is even to this 10 is 8. So 8. Then previous even number is 6. And 4, 2, 0, minus 2, minus 4. Keep on going to the left hand side. So left hand side it is countless. So naturally this set is a what? Infinite set. Sum number 4, x belongs to real number. X is a rational number. What do you mean by rational number? We learnt already what is rational number. Rational number can be written in what form? N by m form. That means if you write it in a fraction form, numerator by denominator form, all such numbers are called as rational numbers. So it is given it is a real number, isn't it? So real number means you can write most probably all the real numbers you can write it in the fractional form. Any number you can divide by 1. So you cannot write it in a set. So I couldn't write it in the set. So it is a infinite set. Now coming to the next subdivision, the same rational number but natural number. Natural number you can almost try, you can write it in the set. The natural number starts from 1. So 1, 2, 3. But rational number means what? It should be in the form of m by n. So 1 can be written as 1 by 1, 2 can be written as 2 by 1, 3 can be written as 3 by 1. Such a way you can write all the natural numbers. So here also it is countless. So it is a infinite set. Now sum number 4. By taking suitable sets A, B, C, verify the following result. Okay. So a question is given. So in this subdivision you have many sums. Only 2 sums will be done by me because you know how to write a set. You learnt in lower class. So it is left as assignment, home assignment. So do it as homework. So 2 problems will be done by me. Okay. Now a result is given that A cross B intersection B cross A, which is equal to A intersection B cross B intersection A. So in this problem, you have to take 3 sets like A, B, C. Don't bother about this universal set, leave it. Just consider about A, B, C only. Okay. So A, B, C, 3 sets you can take of your own. But my suggestion is take very small sets so that you can easily do the problem. So I have taken only 2 elements in each set, and also have at least 1 element is common in all the sets. So sum will be little bit easy. So I have taken 1, 2. So 1 element should be common also. 2 is also taken in B. 2, 3, and in C also I have taken 2. Even if you didn't take common element, no problem. But if you take common element means you can do the problem very easily, right? Okay. Now first we have to find what? A cross B, Cartesian product. So A cross B means what? Set of 1, 2 cross set of 2, 3. So it is the meaning that 1 should be it is a Cartesian product of 1 and 2. Here first element and here first element. So you can write it, Cartesian product will be written inside the bracket, isn't it? So bracket of 1, 2. Here first element and the second and also first element. Then second element, like element in the first set and element in the second set. Just like multiplying, just like an ordinary multiplication. So 1, 2, 1, 3, then 2, 2, then 2, 3. Can you understand? So 4 elements. You can easily count the numbers also. Here 2 elements, here 2 elements. So 2 into 2, totally 4 elements. Okay. Now we have to find B cross A. So take B set first, then A set second. Now here also first element 2, 1, 2 comma 2, 3 comma 1, 3 comma 2. Can you understand? Okay, so that is what it is written here. Right. Now here also 4 elements. Now you have to intersect. What do you mean by intersection? You have to take common elements from both the sets. So A cross B intersection B cross A, which is equal to, from this set and this set we have to check for common element. Only 2 comma 2 is common in both the sets, isn't it? So that only I can take it. So set of 2 comma 2 is the common element, common set in the particular thing. Okay, right. So consider this as equation 1. Now we'll go to the left hand side, A intersection B. So this is A set, this is B set. From both the set you have to take and write the common element. So A set is written, intersection B set is written. So 2 is the only element common, so that is written here. Then B intersection A, you know that B A intersection B and even B intersection A both are same only. So here also the answer is 2. Now both should be done with the Cartesian product. So A intersection B, you should be multiplied with B intersection. It's Cartesian product cross B intersection A. Right. So here the element is 2 only. Here also set of element only 1, which is 2. So 2 into 2, so only 1 Cartesian product is received. Okay, so this can be considered as equation 2. So this is equation 1 and this is equation 2. 1 and 2 are same. So from that we can say this result is verified. That is from 1 and 2, A cross B intersection B cross A, which is equal to A intersection B cross B intersection A. Now we'll go to the next subdivision. Subdivision 4, C minus B minus A, which is equal to C intersection A union C intersection B dash. Okay. Here also A value, set A, set B and set C, all the 3 must be taken off our own only. So the same set of values will be taken. So A, B, C are taken, the same values are taken. Here I have taken an universal set. The reason is we have a dash. So I have taken an universal set. Universal set also how to take, I will say that. So universal set, you take all the elements in A, B and C. So 1, 2, 3 and 4. So in addition to that I have taken one more element. That is more than enough. Okay, right. Now first we will find B minus A. So B minus A, so B set is written minus A set is written. So you know how to do B minus A. B minus A means what? You have to eliminate the element of A from B, then you have to write the rest of the element. So 1, there is no 1 here, 2 is there, so you can just strike out 2, the remaining element is 3, so that is written here, right? Now C minus B minus A. So C minus B minus A means what is set C? 2 comma 4. So set of 2 comma 4 minus what is B minus A? It is 3. So here there is no element 3, so we cannot cancel it. So only 2 comma 4 is the answer. Consider that as equation 1. Now we will go to the left hand side, right hand side. First we will find C intersection A. So C intersection A means this is the C value and this is the A value. So common value from these two sets. So from this set and from this set common value is 2. So I have written. Now we have to find this. Before that we will find what is B dash. What is B dash? From the universal set you have to remove the elements from B. So this is the universal set minus element B. Universal set minus element B means 2 and 3 alone will be taken. So rest of the elements are 1, 4, 5. So 1, 4, 5 are the rest of the elements which is taken. So now this should be intersect with C. So C intersection B dash. So this is B dash, this is C. From these two elements, from these two sets we have to take the common elements. What is the common element? 4. So 4 is written, right? Now you have to unite these two sets, union. So C intersection A union C intersection B dash. What is C intersection A? It is 2. What is C intersection B dash? Which is 4. So 2 set of element 2 union set of element 4. So when you find union means 2 comma 4 is the answer. Consider this as equation 2. So equation 1 and equation 2 are same. So from that we can say that C minus B minus A, which is equal to C intersection A union C intersection B dash. Right? Okay. Now we'll get to the next problem. If n of P of A, this is power set, okay, you know what is power set. So n of P of A, which is equal to 1024, n of A union B is 15, and n of P union B is 32. That is, n of power set of B is 32. Then find n of A intersection B. So first we have to find n of A, then we have to find n of B. Then you know the formula for A union B, isn't it? Using that we can find n of A intersection B. Right. So now we'll take n of P of A, which is equal to 24. What is power set of any element? Power set of any element means it is 2 to the power n. You know that. So I have written 2 to the power n, and 1024 can be written as 2 to the power 10. You know that. So we can take base are same. So n is equal to 10. What is n? N is nothing but n of A. So n of A is equal to 10. The same pattern you have to find the value of n of P of B, which is equal to 32. So n of P of B is equal to 32. So here also it is 2 to the power n, which is equal to what? 2 to the power 5, which is 32. So n is equal to 5. What is n? N of B. So n of B is equal to 5. So n of A and n of B we have found it. Now using the formula we can find the value of the rest. So what is the formula? That is, the formula is n of A union B is equal to n of A plus n of B minus n of A union B. This is the very easiest identity, you know that, right? Okay. Now n of A union is given in the question, what? 15. N of A, just now we have found the value, which is 10. N of B is also found, which is 5. This is what asked in the question, right? Now substitute all the value. That means 15 is equal to 10 plus 5 minus n of A intersection B. So take the n of A intersection B to the left hand side and bring the 15 to the right hand side. So 15 is brought to the right hand side. Now it is 10 plus 5 is 15. 15 minus 15 is equal to 0. So n of A intersection B, which is equal to 0. Sum number 7. N of A intersection B is given as 3 and n of A union B is 10. Find n of power set of A symmetric difference. You know that, isn't it? A symmetric difference B, and this is the formula which is known to us, isn't it? Okay. So this formula is known to you already. It's not given in the question. You learned in lower class. So using the formula only we are going to do this up. Right. So n of A symmetric difference B is equal to n of A union B minus n of A intersection B. It is given in the question itself. The value of n of A union B is 10 and the n of A intersection B is 3. So it is 10 minus 3, which is equal to 7. So that's all the answer. Right. Now in the question you are asked to find power set of A symmetric difference B value. Okay. So same concept only. When you comes for power set means you have to put 2 to the power something. Okay, so 2 to the power, what is the something? What is symmetric difference? That is A symmetric difference B is 7. So 2 to the power 7. So 2 to the power 7 is what? 128. Now justify the truthness of the statement. What is given? See, any element of a set can never be a set of itself. So consider a set. Okay, so a set contains suppose 5 elements. Each element from the set you can take it as a subset. Isn't it? Taking individual elements or grouping 2 or more elements you can write. So though such a way of writing elements is called as power set also, you know that. So every element in a set is a subset for the particular set itself. But it's given that it never be a subset. So the entire statement is wrong. So we can say this is not true, it is not true, it is false. So we say that it is no. Now coming to the next problem. For a set A cross B contains 16 elements and 2 of the elements of A cross B is given here. Find the elements of A. Okay, right. Now first we have to find how many elements are there in A. So first keep in mind that it is given that n of A cross A is equal to 16, isn't it? A cross A element contains 16. It means n of A cross A is equal to 16. What is n of a cross a? N of a cross n of a. It means n of a the whole square. It is like that because both are same set of elements. So n of a the whole square. Okay, it is whole square, not n of a square. N of a the whole square, which is equal to 4 square. Because here we have square, so I have to write 16 as not 2 to the power something, 4 to the power something only. Then sorry, powers of 2. So 4 to the power of 4 square. Okay. So the power is same, 2, and here also 2. It means n of a is equal to 4. That means number of elements in the set A is 4. Can you understand? Right. So we have to find totally how many elements? 4 elements. Okay. Now these are all the 2 elements in A cross A. So first element comes from set A. Second element comes from also set A. Here also first element comes from set A. And second element comes from this set A. But this A and this A both are same only, and see all the 4 are distinct elements, so different elements only. So we can easily say these are all the 4 elements in set A. So elements in set A is equal to set of 0, 1, 2 and 3. Now let A and B be 2 sets such that n of A is equal to 3 and n of B which is equal to 2. Okay. If x comma 1 comma y comma 2 comma z comma 1 are in A cross B, find A and B where x comma y comma z are distinct elements. Okay. Number of elements in set A is 3. Number of elements in set B is 2. Okay. So A cross B is Cartesian product. So n of A cross B means what? 3 into 2 is totally 6. That doesn't matter. Now we know that elements in A is 3 and elements in B is 2. So in the given A cross B, first element comes from where? A. Okay. Second element comes from B. So see, first element is here x, y, z. X, y and z are different elements they have given. So different elements means we have got now 3 different elements. N of A is what? 3. So totally 3 elements. So we can say that x, y and z are the 3 elements of A. Now coming to, that is, this is set A. Coming to set B, second element we have 1, 2 and 1. 1 and 1 are not distinct. So we can consider only 1, 1. So 1 and 2 elements we have got. Now what is n of B? N of B is 2. So totally 2 elements we need it. So 1 and 2 we have already got. So we can say that set B is having only 2 elements, which is set of 1 comma 2. So very simple. Now we'll go to the next problem. If A cross B has 16 elements. Okay, A cross B 16 elements. Now we have to frame a set which is named as S. That set must be a Cartesian product element, that is A cross A. This is one thing. But not all the elements in A cross A will be taken in set S. Okay, the condition is given that when you take elements from A cross A, first element must be lesser than the second element. That is very, very important. So first of all, we have to frame the elements in A cross A. So 16 elements we have to frame. So what is given in the question means minus 1 comma 2 and 0 comma 1 are the 2 elements of S they have given. Okay. So in set S, how many elements are there? We don't know, but 2 elements are already given. Now first we have to find A cross A 16 elements. Okay. Okay, right. So to get into those 16 elements, we must know what are the elements, how many elements are there in A. Previously we have done this, isn't it? In the previous slide we have seen the same procedure we are going to follow in this particular problem also. So in the question it is given that n of A cross A is equal to 16, isn't it? Number of elements in A cross A is 16. So it means that n of A into n of A is equal to 16, that is n of A the whole square is equal to 4 square. So n of A is equal to 4. So number of elements in set A is 4. Okay. Now see here, these 2 elements belongs to set S. Set S is framed by taking elements from where? A cross A. So 1 comma minus 1 comma 2 and 0 comma 2 are the elements of set A also, A cross A also. Okay. Now first element comes from A, second element also comes from A. Here also first element comes from A, second element also comes from A. All the four elements are distinct, it means different. So we can take these are the four elements that set A contains. So number of elements in set A is 4, and what are the elements in set A is -1, 0, 1 and 2. Right. Now okay. Now you can easily frame it. Okay. First A cross A. How will you find A cross A? Cartesian product. A cross A means this is the set of elements A cross the same set. Now we have to find what set S. So set S is equal to set of. Now keep that in mind that first element must be lesser than the second element. Now you take first of all the first element is -1. Here first element is -1. Both are same. We cannot take it. Then we go for the next element which is 0. That can be considered. So -1, 0. And this is also greater number. This is also greater number. This is equal to. So -1 cross -1 comma 0, -1 comma 1, -1 comma 2. Now coming to the second element 0. So 0 is lesser than what? 1 and 2 only. We cannot take the two elements. So leave -1 and 0. 0 is lesser than 1 and 2. So 0 comma 1, 0 comma 2. Now coming to the next element which is 1. So 1 is lesser than 2 only. We cannot take -1, 0 and 1. Only 2 can be considered. So 1 comma 2 is the set. Now coming to the last element 2. 2 is lesser than no elements. All the elements in the second set is greater than, all the elements in the second set is lesser than or equal to. It is not greater than. The condition is A must be lesser than. So these are elements which is greater than or equal to 2. So we cannot find any Cartesian product using the element 2. So totally set S contains 1, 2, 3, 4, 5, 6 elements. The question you are asked to find the remaining elements of S. These two are already given. What is that? -1 comma 2 and 0 comma 1. So leaving the two elements, remaining elements are 4. What are they? -1 comma 0, -1 comma 1, 0 comma 2 and 1 comma 2. So that's all about today's exercise. So exercise 1.1 is over. Copy down in the notes.